sequence. So this looks like 11. This looks like 13. This looks it is 15, and this is 17. That's the first difference. If I take this second difference, looks like 2, 2, 2. All right. So the quadratic part of this sequence, well, if I divide 2 by 1, it's just n squared, right? There's no need to write 1. So what does this sequence look like? And by now, you know it's 1, 4, 9, 16, 25. So we're going to subtract the initial sequence minus this sequence. So 9 minus 1 is 8. 20 minus 4 is 16. 23 minus 9 is 24. 48 minus 16 is 32. 65 minus 25 is 40. Okay, so start again. So our expression so far, let me write it here. No, let me write it here. It's n squared. And there's more. Now we start again, and then look here. There's another sequence inside. So there's another sequence in here, right? There's the n square sequence, and there's another one, and we're gonna find out what that is. So again, if you take the first difference, well, 8 to 16 is plus 8, plus 8, plus 8, plus 8. So now that 8 we place over here. So it's an 8n sequence, a sequence that goes by 8, right? An 8n sequence, substitute with the first term in an 8n sequence would be 8, the second would be 16, this third 24, 32, 40. Notice that we don't have to make an adjustments because when you subtract 8 minus 8 is 0, 16 minus, you know what, let me put it like this. 16 minus 16 is 0, this is 0, this is 0, this is 0. So it's just n squared plus 8n. Now, let me confirm if this is okay. So if I plug in the number 3 in here, I should get 33 because that's the third term. So the third term is 33, so 3 squared plus 8 times 3. 3 squared is 9, 8 times 3 is 24. Do I really get 33? I do, look. So the third term is indeed 33. This fifth term should give me 65. So again, 8 squared plus 8n, and if I replace n with 5, I have to get a 5 plus 8 times 5. 5 squared is 25, and then 8 times 5 is 40. Look at that. So my fifth term. So again, I checked with 3 and I checked with 5, and I confirmed that this is my nth term. That's the expression, right? Now, some of you made a mistake here. So the last question here. So let me tell you what this is: 8n squared plus 8n. Now, I wanted you to tell me which term has 800. Let me actually, you know what? I want you to tell me, like, the third term is 33, the first term is 9, so like I just did right here. If I plug in 5, it gets 65. What number can I plug in into this expression right here and get 825? That's the question. So I'm going to use the space here. So now you can guess and check, right? Let's see. If I pick 20, 20 squared is 400. 8 times 20 is 160, and 160 plus 400 is 560. So 20 doesn't seem. If I pick 30, well, if you pick 30, right? So here's my expression, n squared plus 8n. And if you say the 30th term, will it give you 800, 825? Will that equal 25 when I plug 30 in here? Well, that's too much because, look, the moment you put 30 squared, that's already 900. So 30 is not it. So it's a little bit above 20, and so it's between 20 and 30. Well, let's try 25. If I plug in 25 over here, and then 8 times 25, let's see what I get. So 8 times 25 is, let's see, 8 times 25 is 200. 25 squared is 625, right? If I add this to, I get 825. Is that what I'm looking for? Yeah, it is. Look. So n is 24. When n equals 25, the number of my term is going to be 825. So that's what I'm looking at. And you do guess and check. Obviously, your estimate skills come into play here, but that's what you would do. Second question. Same thing, except that this one I gave you the visual as well. So if you have a choice of doing that first difference, second difference, or you can figure out using this. Okay, so it's really up to you. So I'm just going to say that, let's see, this is a 3 by 1, 2, 3, 4, 5, 6, 7, 8. So there's 24 squares in here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4 is 32. 32 plus 6 is 38. So there's 38 squares in here. This one is a 1, 2, 3, 4, 5. 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 times 10 is 50. It's 56. So figure out, let me write that down here. So that's 20. So I'll write it over here, right? Let me cross this out. So the first term is 24. The second is 38. The third is 56. I mean, you can play with the visual and ask, you know, you can even, what I would suggest if you're doing the visual is think about, how would you draw the fourth term? So notice that this was 3, right? And now it's 5. And this, sorry, 3, 5. And this is 1, 2, 3, 4, 5. Am I doing this right? I count this right, sorry. This is 3. This is 4, and this is 5. 5. If you were to draw the next picture, guess what? This would be 6, right? And then let's talk about this side here. I think it's easier if you talk about this. This is 1, 2, 3, 4, 5, 6, 7, 8. There's 8 over here. This is 1, 2, 3, 4, 5, 6, 7, 8. This is also 8, but there's 2 more here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so that's 10, which make, so this would be 10 over here. And this would be 12, right? You can, again, we're doing just to get more information. You can see how visually it's going. So I know that if I were to draw the next one, let's see how I would draw this. The fourth term, sorry, this is not 8, is it 8? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is, and notice that this is 8, that's 10, this is 12, the whole thing is 12. This would be all the way down here, and we can say that that's 14, right? So this is a 3 by 8. This would be a 4 by 10 minus 2. This could be a 5 by 12. So there's 2 missing here. There's 4 missing here. This could be a 5 by 12. Missing 4. This would be a 6 times 14. And I guess just going by this, 0, 2, 4, 6. And I think we would be taking 6 from here, right? A 6 by 14 minus 6. This is minus 4, minus 2. And again, you get my point. And you can use this visual to help you find the nth term. Up to you, whichever one you want to do. And then, well, let's just use this one. I think that would be easier. 24 is 38. That would be 14. So the first difference here, this takes me to 14. 56 minus 38 would take me to 18. And then if you do plus 4 over here, that would be 22, which makes the next term 78, right? And then obviously you can take the second difference, and that would be 4, this would be 4, and obviously that would be 4. So that we have a quadratic sequence with n squared and with a coefficient of 2, right? Because we take 4 and divide by 2, and that's how I get the number over here. So now, what are the first 5 terms of a 2n squared sequence? Well, it'd be 2, 1, and then 4 would be 8. And then 1, 4, 9, it would be 18. And this would be 32. If we subtract, and I'll put this in parentheses, 2 minus 20, 24 minus 2 is 22. That would be 30. 16 minus 8 is 8. And then 4 minus 1 is 38. So this plus 8. That's a and then 7 minus 3, 46. Right? So again, so now we have another sequence. I'm going to start the whole process again. Take the first difference. Note this is plus 8, plus 8, plus 8. So we know there's a linear sequence here that goes by 8. 22, 30, 38, 46 is the same thing as the sequence that goes by 8. And that sequence, and an 8n sequence starts with 8, 16, 24, 32. But I have to make a little adjustments to this sequence to look like 22, 30, 38, 46, right? So let's subtract and that'll give us the answer. 22 minus 8 is going to be 14. That's 14, that's 14, and this is 14. So here are the three parts of our expression. 2n squared plus 8n plus 14. And that's going to give us the number of squares in each of these pictures, right? So in the first picture, we should have, and again, what did I write here before? Did I just erase it? No, I didn't. So it's a 3 by 8, so we have 24. Well, plug in 1 in here. If you plug in 1 in here, you get 2 times 1 squared, which is just 2, plus 8 times 1, which is just 8, plus 14. 8 and 10 is 8 and 2 is 10, and then plus 14 is 24. Look, so when n equals 1, it does give me 24. You can plug in when n equals 2, does it give you that? When n equals 3, does that give you the number of squares? I'm going to say that it does. Now, which term and when n equals what number does it give you 986 squares? And that's what you had to figure out for part 2. Again, guess and check, but you know, it's not, you can use your estimating skills. So let's try, well, if you try 30 squared is already 900, right? So if I plug in, so I have the expression 2n squared plus 8n plus 14. So if I say n is 30, well, I know I'm going to be above because 30 squared is 900, and 900 times 2 is going to be 800, so definitely not 30. Maybe half of that. Let's try 15. So if I try n equals 15, let's see what I get. I get 2 times 15 squared plus 8 times 15 plus 14. 15 squared is 225. 225 times 2 is going to give me 450. 8 times 15 is 40. Carry 4, so that's 120 plus 14. So 450 and 120 is 570. And 570 plus 14 is 584. So 15 is way too small. That's not going to work. Let's say 20. 20 squared is 400. 400 times 2 is 800. 800, 160. Let's try 21. I'm going to try n equals 21. So 2 times 21 squared plus 8 times 21 plus 14. 21 squared is 441. 441 times 2 is 882. So this gives me 882 plus 8 times 21 is going to be 168 plus 14. And that's too much, right? That's way too much. No, it's not 21. Huh. 19? What happened was 20, so 20, let's try 20. When n equals 20, what do I get? So that's 400. 400 times 2 is 800. 8 times 20 is 160 plus 14. So that's going to give me 964. Unless I wrote 986 incorrectly, guys. 960, 964. Are you saying it can't be 21? Can it be 21? All right, 2 times 21 squared plus 8 times 21 plus 14. So times 2. So this is going to give me 882 plus 8 times 21 is 168 plus 14. Let's add this up. 882 plus 168 plus 14. That's above 1,000. So I think I did this 986 incorrectly. So I probably meant 20. I don't think this number is incorrect, unless I did this wrong. Let me just verify this again. When n equals 2, I get 2 times 2 squared plus 8 times 2 plus 14. This is 4. 4 times 8. 4 times 2 is 8. Plus 16 plus 14. This is 38. So I should have 38 squares in here. This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So that's 32. And 32 and 6. Because there's 6 here at the bottom is 38. So this expression is correct. I think I just did this incorrectly. Well, unless I did something wrong on this side, I guess you guys can figure this out. 20 didn't work. Give me a second. Times 2 plus 160 plus 14, 970. I don't think this number is correct, guys. So again, if you get stuck here, don't worry about it. Hopefully the two of you will watch the video and say something to everybody else. I think the number is supposed to be 974. Okay, and again, he'll obviously tell me tomorrow morning. Right. Okay, so that's the quadratic sequences. Okay, let's go through this. This is pretty much combining like terms, and I'm gonna actually write this whole thing, and then because we know where I'm just gonna write it. Okay. This is how much he mowed on Monday. X squared minus 12x minus 7. That's Monday plus Tuesday. Sorry, plus Tuesday. 3x squared minus 1 plus Wednesday. And that's what you should start with. That's what we're doing, right? We're adding all three. Now, I'm going to remove the parentheses. When I remove the parentheses, in this case, nothing's going to change because you either can think of it two ways. There's a plus in here and there's an invisible one. You can do this treaty property, right? But with 1 times 8 is just 8. 1 times negative 12 is negative 12. And 1 times negative 7 is negative 7. So nothing changes when there's a plus sign in front of the parentheses, right? And you multiply with whatever coefficient. As far as the sign goes, nothing changed. So 3x squared minus 1, it's going to come out of the parentheses as plus 3x squared minus 1. And this, same thing, is going to come out as plus 7x squared plus 5x minus 9. Everything that was inside, however they were inside, comes out exactly on the outside. Okay, now I'm free to combine my terms. And we're going to start with anything that has x squared. This guy, and this guy. Notice they're all positive. So 8 plus 3 is 11, plus 7 is 18 x squared. I don't do anything with the variables. Next one, anything that has just an x. So we have this guy here and this guy here. But notice that this is negative 12x and this is positive 5x. Negative 12 plus 5 is negative 7x. And lastly, anything that is just a constant, meaning, what do you call it? Just an old-fashioned number. So I have negative 7, negative 1, and negative 9. So if you want to pull it to the side, write it. Negative 7 minus 1 is negative 8. Negative 8 minus 9 is negative 17. So this is how much he mowed for all 3 days. Okay? Now the bottom question, so let me write the answer here. 18x squared minus 7x minus 17. So that's what he did Monday, Tuesday, Wednesday right here. It says here that for the whole week, though, he did this. Monday to Sunday, I guess you want to call it. That's how much he mowed. Now, if this is Monday to Sunday, Monday to, I guess, Friday or Monday to Sunday, I don't know what the week goes. Monday, let's say to Friday. Okay, Monday to Friday, that's the total. And this is Monday, Tuesday, and Wednesday. So you agree that if I take this guy here and subtract Monday, Tuesday, Wednesday, whatever answer I'm left over will be the Thursday and Friday. So the whole week, he did 20x squared minus 12x minus 9. Put it in parentheses. Minus, and a lot of you didn't do that, minus what he did Monday, Tuesday, Wednesday. And again, put it in parentheses because it's more than one term. Okay? Before you subtract, you have to remove the parentheses. So this one stays the same because there's an invisible plus sign here, so nothing changes. 20x squared minus 12x minus 9. But this, because of this minus sign, everything else, everything that's in parentheses comes out the opposite. So that instead of 18x squared comes out as negative 18x squared. The negative 7x becomes 7x plus 7x, and the negative 17 becomes plus 17. Now you can combine that term. So we get this guy here and this guy here. They both have x squared. Okay, so that's 20 minus 18, which is 2x squared. Don't do anything with the variables. Next one, negative 12x and plus 7x. You can combine those two. And it's negative 12 plus 7, which gives you negative 5. And please write down the x. And don't do anything with the variables. You're just literally adding or subtracting the coefficients. And then lastly, in triangles, negative 9 and positive 17, which gives you plus 8. That's your final answer. Combine like terms. When you combine like terms are terms that have same variables raised to the same exponent. Okay, so when I'm adding 3x squared plus 8x squared, for example, literally take care of the coefficients. So 11x squared. And this, we don't do anything with it. We're adding. Or even in subtraction, it's the same thing. We add or subtract the coefficient, and we just copy down the variables. Okay. Now we have same thing. Do the distributive properties, multiplying. Right? And you got to multiply and be aware of the signs, and obviously you have some variables to take care of. So let's do the first one. Negative times a negative is a positive, so let me write that down. 3/5 times 15. So look, what's 3/5 times 15? If you pull it, write it to the side here. If you can't do it there, write it to the side. And I'm sorry, but I forgot even something here. 3/5 A times 15. So imagine you had these two to multiply. Well, the 15 as 3 can be simplified to 3. Right? Because 15 divided by 5 is 3. Great. Now we're left with 3 times A times 3. Again, there's an invisible multiplication symbol there, right? So 3 times A times 3. Again, I get 3 times A times 3. Well, 3 times 3, we're going to multiply these, right? The numbers. 3 times 3 is 9. What are you going to do with the A? Throw it away? No. Stays there. Together. So the first one, negative and negative is a positive. 3/5 A times negative 15 is positive 9A. There you go. Second part. Again, I'll pull it to the side. Negative 3/5 A times negative 175K. Okay, and again, look, there's multiplication. In multiplication, we can move things around. So first of all, negative times a negative is again positive. Okay, 3/5, you can multiply 3 times 175 and then divide it by 5. Or divide 175 by 5 and multiply by 3. It's whatever you want. Okay, so I'm going to simplify 175 and 5. Okay, 175 divided by 5 is 35. I'm left with 35. 35 times 3 is 105. So this becomes 105. And what do you do? What are you going to do with the A and the K? Well, it's still there. So it's 105. 105 times A times K. There we go. Yeah? 105 times A times K. And then the last one, negative times a positive is a negative. And then what is negative 3/5 A times 20M? This one's a little easier. 20 divided by 5 is 4. And then 4 times 3 is 12. 12M. Okay? And we're done with the first set of parentheses. Now the second one. It's negative 16M, and you're multiplying first times 18M. Right, that's my first of all, negative times a positive. The 18m is positive. It's a negative. There, I put the sign. 1/6 times 18. What is 1/6 times 18? We can divide 18 by 6 and get 3. So we're left with 3. And then we have m multiplied times m. What is m times m? Well, m times m is m squared. Next one. 1/6, negative 1/6 m times negative 36a. So there's a multiple. Everything's being multiplied. Right? Well, negative times a negative, first of all, is a positive. 1/6 of 36, that's 6. And then what are you going to do? M times a. We'll do it alphabetically. So you actually write am. Right? Again, remember, we're multiplying 1/6, negative 1/6, times m, times 36, times a. That's right. You can move these around. So I'm going to write negative 1/6 times 36 times a times m. Right? Just moving it around. This was simplified. We got 6, and that explains that 6. And a times m is just am. And then finally, minus 24ak. That's the first part. Second part, now we got to combine like terms. Well, let's start with the thing that has the term that has the highest variable, height exponents. Let me change colors. Negative 3m squared. Nobody else has an m squared, so that's going to stay the same. And then after that, I'm going to do it alphabetically. So plus 9a, I'm going to write it right here. And then we have anything with a, yeah, we have. This is, change colors. This is AK, and there's something here that says AK, right? That's 105, so plus 105 AK, and this is minus 24, so we're going to do 105 minus 24, and that's going to give us 81, right? Because this is positive 105, so it's 105. Literally, it's 105 AK minus 24 AK. Well, the AK stays. First of all, 105 minus 24 is going to be positive 81. And then we have something that is AM, but there's nobody else that's an AM, so that does absolutely nothing. Just still part of your answer, though. And finally, minus 12m. And that combines with no one, because there's no other term out there that has simply an m. That's it. You know what the weird part of this question was? That not no one, I should say, but a lot of you wrote your work here and here and here. See all this empty space here? First rectangle is the big one. We want to find the area, and this is 5c, right? And this is 5c minus 12b plus 9. How do we find the area of a rectangle? Base times height, length times width, whatever you want to call it. So let's multiply 5c, right, times the other one, and the other one I have to put in parentheses. Right, so I'm multiplying this side times this side and gives me the area. So I'm going to have to do this period properly. 5c times 5c. Well, here's what you have. 5c times 5c. Well, 5 times 5 is 25. And what's c times c? Well, c times c is c squared. Done. Next one is 5c times 12b. Well, it's 5 times c times negative 12 times b. That's what you have when you multiply this one and the middle term. Well, 5 times negative 12 is negative 60. Done. And then c and b multiplied, well, you can't do anything with it, so it's just bc, right? So we're going to write it. Last one, positive times a positive is a positive, and then 5, you get 5 times c times 9. That's what you have. 5 and 9 is 45, so we're going to write that as 45c. That's your first rectangle. Now we have a small rectangle inside. And the small rectangle inside, the height here, or the width, is 3/4 C, and the length here is C plus 60B plus 12. Just likewise, we're going to have to do length times width, so length times, and the other one is C plus 60B plus 12. You're going to have to do the Streeter property again, so let's do these two. 3/4, so we have 3/4 C times C. Well, 3/4, there's nothing to do with 3/4, but C times C, we can write it as 3/4 C squared. And then we have 3/4 C again, change colors, 3/4 C, which is this guy, times 60B, times 60B. So it's times. Well, we can do 3/4 times 60, which is 45, positive, by the way, right? They're all positive. And then C times B, and let's just write it alphabetically, it's BC. Done. The last thing we're going to multiply, change colors, is 3/4 C again, right? Because it's the outside term. 3/4 C times 12. Well, the C is going to do nothing because there's no other variable. That's just C. So let's take care of 3/4 times 12. Well, that's just going to be 9, right? 3/4 of 12 is 9. Positive 9C. All right, so the area of the small rectangle is that. The area of the big rectangle is this. So what did we need to do? We needed to subtract this guy right here on the right from the left side. Let me erase. All that's taken care of. Now take this guy over here. I'm going to rewrite it. So 25C squared minus 60BC plus 45C, that's the area of the big rectangle, minus this guy here. And we have to put it in parentheses, minus 3/4 C squared plus, 3/4 C squared plus 45BC plus 9C in parentheses, right? And we write in parentheses because there's more than one term, and we have to now change the signs of the terms inside. So all right, first parentheses, nothing happens. So everything comes out the same. Third parenthesis, well, this one second parentheses, right? Because of this minus sign, everybody inside changes. So that 3/4 C squared comes out as negative 3/4 C squared. Plus 45 BC becomes minus 45 BC. And the plus 9C becomes minus 9C. And you have to really be careful. And again, if you want to picture there's a 1 here and do the Streeter property, it's the same thing. Combine like terms. Let's combine like terms. Anything with a C squared, yeah, there's 1 over here and there's 1 over here. Well, 3/4 is 0.75, right? So 25 minus 3/4 is actually 25 minus 0.75, which gives us 24 1/4, or 24.025 C squared. Done. BC, there's anything BC? Yes, there is. This is a BC, but that's negative 60 BC, and this is negative 45 BC. So think about what you're doing. We're doing negative 60 BC minus 45 BC. If you want to change this to an addition problem, it becomes negative 60 BC. Negative subtraction becomes positive, and the opposite of 45 is negative 45 BC. Right? So it's negative 60 plus, so it's a negative plus a negative. We are going much further left on the number line, so we get a smaller number. Negative 60 and negative 45 is negative 105 BC. Is there now the C? There's a positive. Let me change colors. There's plus 45C, and this is minus 40 minus C. Well, plus 45, so it's 45 minus 9, which is plus 34C. This is my final answer for this problem. Okay. Last question, really. That was this one. It's literally, there's nothing to do here. Let's just combine like terms. So let's start with anything that has a squared b. Let me circle it. So anything that has a squared b. Well, there is this guy right here. So let me write them side by side. Imagine they're rocks and I'm moving these rocks, right? Next one, AB cubed. So this guy's an AB cubed and this guy's an AB cubed, but this is a minus 12 AB cubed. This is plus 13 AB cubed. And the last two terms are going to be minus 23, minus 2, right? Now we get to combine. There's no reason to write like this when we combine. So these two, negative 18 minus 5, we're subtracting these two, so it's just negative 23, and we do nothing with the variables. We just subtract the coefficients. Negative 12 plus 13, right? It's just plus 1, positive 1, AB cubed. You didn't need to write the 1, I just wrote it for convenience. And then the last one, negative 23 minus 2 is negative 25. So that's the answer to that problem. Okay. Now the rest, I'm not going to do all of them, but I broke it up into parts. All right, so if you look at this whole section here, this is for you to practice what happens when you're multiplying. Well, let's do the first one. So I'm going to write 3. So and again, I know there's no multiplication sign between the 3 and the x, but there's an invisible one. That's what that says. 3 times x to the 9th power times y to the 9th power times 6 times x to the 4th power. That's what it is. I can move it around. So imagine if I told you to multiply 5 times 2 times 4 times 3. Well, if I wanted to do 5 times 4 times 3 times 2, would that change the answer? No, I can move things around, right? Community property allows you to move it around. So let me move the 3 and have the 6 next to each other. Let me have the x to the 9th power times x to the 4th power next to each other, and then the y to the 9th power by itself. Again, but we're still multiplying, so I can multiply these two. I get 18. X to the 9th times x to the 4th, we keep the base as the exponent. We get x to the 13, and then times y to the 9th. So that's the answer to the first one. And let me just go back here to y x to the 9th power to x to the 4th power is equals x to the 13. This is in what they call exponential form. So what's x to the 9th powers? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. X times x times x 9 times, right? Times, and guess what? 4 more. 1, 2, 3, 4. So now they're all being multiplied. So if I showed you all these x times x times x times x 13 times, and I said, how can I rewrite this? Use an exponent, you would say, well, that's easy. It's x to the 13th power. Or if I gave you 2 times 2 times 2 times 2 times 2 times 2, and I said, that's the exponential form. Sorry, expanded form. What would be the exponential? Well, this is the same thing as 2 to the 1, 2, 3, 4, 5, 6 power. No, it's the same thing here, except that we're using letters. Okay. 6, well, I can multiply 8 and 10, I get 80. The x's, I have x to the 5th and x to the 5th, so x to the 5th and x times x to the 5th is going to be x to the 10th power, right? Keep the base out of the exponent. Y to the 5th times y to the 4th would be y to the 9th power. And that's it. When we're multiplying, here, multiply 7 and 5, my coefficients, 35. X, is the x multiplying with anyone? No, but I still got to write it down. And then we have y3 times y3 gives me y to the 6th power. Okay. I said I wouldn't do everything, but I'll do it. So now we have negative 6 times 2 times negative 2. So it's a negative times a positive times a negative is going to give me a positive. So 6 times 2 times 2 is 24. Done. x8, x4, and x8. So x to the 8th. So we have x to the 8th times x to the 4th times x to the 8th. Well, keep the base, add the exponent. It's x to the 20th. And then y to the 7th and y to the 3rd is y to the 10th. Okay. So I'll let you do the rest in this section. Okay. And if you have questions, you can tell me. Okay, this section here has you practicing the distributive property. So I'll do a couple here. Let's do the first one. Distributive property. So 3, well, first of all, it's positive times a positive, which is a positive. 3 times 2, 6. A cubed times a, well, remember that a has a little 1 there. So it gives me a to the 4th power, and don't forget to b. So literally what we just did was 3a the third power b times 2a. We multiplied 3 and 2, got a 6. A to the third power and a gives me a to the fourth power, and the b we can't throw it away, and that's what it is. I get 6 a fourth b. Now the second part of our distribution has us multiplying 3a to the third power b times negative 9b, right? So it's this guy times this guy. So first of all, it's going to be a negative, so here's my negative. 3 times 9, 27. A cubed multiplies with no one, but still part of our answer, and b times b is b squared. So that's my final answer for 15. Let's do 18. Again, it's this times this, this times this, this times this. Take care of the signs first. So this guy is negative, and the first term in my parentheses is positive. So negative times a positive is a negative. Done. 2 times, well, there's an invisible 1 there, so 2 times that invisible 1 gives me 2. Done. X to the 4th times x squared gives me x to the 6th. And then I'll write the y, and I'll write the z, right? Because they have to tag along. Second, negative times a negative is a positive. Again, it's 3 times this invisible 1 gives me 3. Let's see, x4 here, right? x4, and there's no x here, so x4 just x4. Y cubed times this y over here, it's going to be y to the 4th. And then there's a z here and a z here. Z times z, z to the 2nd power. And then we're going to repeat this guy again, the factor outside times 5y. Well, negative and a positive is a negative, times a positive negative. 5 multiplies by invisible 1 gives me 5. X to the 4th power is just x to the 4th power. Y to the 3rd power times y is y to the 4th power, and then z. Can you combine anything? No, because all these, they're all different. There's nobody that has an x to the 6th power y cubed z. Everybody's different. Well, yeah, everyone's different. This almost looks the same. The x to the 4th power are the same. The y to the 4th power, but the z's are not to the same power, so they're not like terms. That's it. That's your final answer. Let's do 24. I'm going to skip around. And again, if you have questions, we'll take care of it. Negative times a positive, so we're multiplying these two. Okay? Negative times a positive, first of all, is negative. What's 3/8 times 24? Well, 24 divided by 8 is 3, and then 3 times 3, I get 9. Again, 3/8 times 24. You can simplify. And then 3 times 3 is 9. That's how I get it. And then we're multiplying. I'll write it out. 3/8 a cubed b squared times 24ab. That's what we're doing first. So we took care of the coefficients and we got 9. So now we have an a to the 3rd power times a. That gives me a to the 4th. B to the 2nd power times b. That gives me b to the 3rd. So that's done. Now we're doing that times this. Let me rewrite it. Negative 3/8 a cubed b second times negative 42b cubed. All right, so first of all, it's a negative times a negative, so it's going to give us a positive. 42 divided by 8, so please don't write decimals. Especially, you can write decimals if they're terminating decimal, but if they're like 3.66666, some of you wrote 3.66. Right? That's not really the same thing. So leave it as a fraction. Can we simplify? So we're multiplying 3/8 times 42. We can divide this by 2, which is 4. This is 21, and that's as far as you can go. So 3 times 21 is 63. So we're going to get 63 over 4. And the variables, well, a cubed multiplies with no one. But the b to the 2nd power and b to the 3rd power can change to b to the 3rd. So that's the answer for 24. So now you have a whole section of distributive property that you can practice. This from 1 to 16 was literally just combined like terms. Nothing crazy here. 3a plus 4a. Can I combine these? Yes. When you combine like terms, when you're adding, subtracting, all you do is work with the coefficients. So 3 and 4, is 7. And 7 what? 7, 8. That's it. That does not say 3a times 4a, which is different. Then you multiply. 3 times 4 is 12. What's a times a? That's a squared. But when you're adding and subtracting, the variables don't change. Don't do anything with the variables. This one, they're all b's. Okay, so I know my answer is going to be something b. Here, I need my coefficient. Negative 12 plus 6 is negative 6. So negative 6 minus 4 is negative 10. So my final answer is negative 10b. Pick something at random. Let's pick number 10. Is there a 3r cubed t? 3r cubed t. No. So 3r cubed t combines with no one. Let me move on. Is there anything with a 5rt squared? Rt, there, yeah, look, right here. And take the sign that comes before it. So that's how you know if it's positive or negative. So they're both positive. 5, so it's 5 plus 6, so just add the coefficients, and the variables stay exactly the same. RT, well, there's something here that says RT, negative 6 RT. There's something else here that's RT. So it's going to be something RT. And negative 6 plus 4 is negative 2. And finally, the 5 minus 3 is going to be positive 2. And that's it. Guys, we're adding and subtracting. And I'm just asking you that on top of that, just that you add and subtract terms that I like. Okay, that's the only difference here. Let's do 15. Let me circle 4x cubed. Is there anything that's cubed? Yeah, there is. Look, 4x cubed, sorry. No. So 4x cubed does absolutely nothing. Y cubed, yeah, there's a y cubed here. There's another y cubed here. So negative 6 and negative 25 is negative 31 y cubed. This one, x squared y. Is there anything that says x squared y? No. So plus 3x squared y. And before you say anything, this one, it's actually not. It's there was a 4x cubed and there's a 5x cubed here. So 4x cubed plus 5x cubed is 9x cubed. Okay. And then finally, is there a 2xy squared, xy squared. Yeah, this guy is xy squared. So they're both xy squared, both positive, makes the life easier. And 2 plus 3 is just 5, and then copy the variables as they are. That's it. Okay. Please, for 16, notice that we have 3 parentheses. Before we combine, we got to remove the parentheses. So the first one, well, there's no signs there, but it's understood that there's a plus sign when you don't see one. What did I tell you about having a plus sign in front of parentheses? Well, when you remove the parentheses, everything that's inside comes out exactly as they are. This one, they come out as plus 6x squared minus 5xy plus 3y squared, and likely for the same thing for the last one. Nothing changes. Right? And then you get combined like terms. Let's see if I can do this. 3x squared, 6x squared, 9x squared. They're all x squared. They're all positive. So 3, 6, 9, that's 18. Good. Y squared. There's apparently a y squared here, a y squared here, and a y squared here. So that's 4 plus 3, which is 7, and 7 minus 25 is negative 18 y squared. XY, this is an XY, this is an XY, and there's only 2 XY, good. So it's 2 and minus 5 gives you negative 3 XY. And that's the final answer for that one. Okay. Now the next section, I'm pretty sure is subtraction, if I remember correctly. Yes, it is. So a little bit of subtraction with a little bit of distributive property. So let's do number 3. I'll do number 3 right above it. Distributive property, 5 times 4 is 20, x squared. 5 times negative 8 is negative 40, x. 5 times positive 3 is plus 15. Done. Second one is these. Negative 7 times 6 is negative 42x squared. Negative 7 and negative 4x is positive 28x. Negative 7 and plus 11 is plus 77. Once you do that, you can combine like terms. We got these two that are like 20, negative 42 is negative 22x squared. Negative 40x and 28x are like terms, so that's going to give us negative 12x. And then finally, positive 15 and positive 77 is going to give us 92 positive. Okay. So again, it's just a little exercise on what to do, right, on you getting used to, hey, for example, 11, when there's a subtraction sign in parentheses, when I remove the parentheses, this becomes 8x. 5y, which is positive right now, is going to come out as minus 5y. The plus 4x comes out as minus 4x. Can I combine like term? Yeah, the 8x and the minus 4x equals 4x, and then the 5y combines with no one, so it's just minus 5y. 13 and 14 is exactly, you know what, let me do 14, I think. Well, yeah, let's do 14. I don't do everything, but 14. Negative and the positive is a negative. Let me write that. Half of 12 is 6. X and x cubed gives me x4. Y multiplied with no one, but still there. Z and z4 gives me z to the 5th power. Negative and a negative is a positive. What's half of 18? It's 9. Well, x times x is x squared, and then please write y times z as well. Next we have these two, negative 5 and positive 2 is negative 10. Y times x, so notice that they're all different variables, so we just x squared, y, z. Okay? And then negative times a negative is a positive, and 5 times 20 is 100y. Are there any like terms here? Well, there is. Look, these two are exactly the same variables with the same exponents. So this guy, I don't do anything with it. These two, 9 minus 10 is going to be negative 1, right? And then copy the variables as they are. And then don't forget the plus 100y. Okay. All right, so that's what we're going to do. Hopefully you worked around with the other ones. I will do, well, let me do this. Let me do 17. 17, then we have a triangle. So again, I don't know what kind of triangle, but I know they tell me that this is 4x minus 7. They tell me that this is 3x plus 4. And you're asked to find this guy. Well, you know that the total perimeter is 12x plus 15. So if the three sides added is 12x plus 15, so if I subtract 3x plus 4 and 4x minus 7 from this total, I should get whatever the third part is. So let's do that. So it's 12x plus 15, which represents the perimeter of the whole triangle, minus, we're going to take minus this guy, and then minus this guy as well. But notice that I put everything in parentheses, right? Let's remove the parentheses. So I'd get 12x plus 15. Now what happens here when there's a minus sign in front of parentheses, it becomes minus 3x, minus 4, and this becomes minus 4x, and positive 7, right? Because you have to do the opposite. So combine like terms, the 12x here I can combine with a minus 3x and the minus 4x, and that's going to give us 12 minus 3 is 9, 9 minus 4 is going to give us 5x. Then we have a 15 minus 4 plus 7. 15 minus 4 is 11. 11 plus 7 is 18. So positive 18. So this missing side here is 5x plus 18. If you don't trust me, add 5x plus 18 plus this. You should get 12x plus 15. You should. Okay. combined like terms. This one is just combined like terms. This one is just combined like terms as well. Okay. I'll leave it at that. I don't want to make the video too long. If you have any questions that you want to work on in class, or you're confused, then let me know in class, and I'll do it in the beginning. Okay. Oh my God! Please tell me this was recording. Hang on, guys. Yes, it was.